So thanks. I'm going to talk about writing perfect documentation using Restructured Text and Sphinx. This is female developer Cleopatra assisted by Sphinx in writing technical documentation. The objective is to improve developer experience. So write better docs, stay concise, and never miss a detail. So these three combined. And because this is a beginner talk, I'm going to briefly cover the restructured text basics. So these are the headings. These symbols, it's not strictly said what it can be. For me, it's most logical that this is the most important one, the H1, and this is the H2, and this is H3. But in restructured text, it can be anything, any symbol, as long as it's consistent. And it's also better if you have the documentation, you have certain ways of doing it. You could better document this as well, so that it's easier for new people to come. So these are the paragraphs. This is how you write them in structured text. The list, so unordered list and ordered list. This is how you do it with images. So this is this strange notation. You give an image, you give a width, and optionally the text for the image. Links, there are many types of links. For me, these two are most useful. This is the link definition, where you define the link and then you can reuse it like this in a text, very useful. Or just inline link, if you just write something once. And this is on the right side how it's rendered. Some basic emphasis for text. So a single thing, it will make it single symbols wrapping a word or words. They'll make it italic. Two, they'll make it bold, and these are literals, inline literals. And this is the way to highlight that something is a code. So this is code block, and then you say which language highlighting do you want to have it, and then Sphinx will ensure that this is properly highlighted any way you want. And this part I'm going to speak mostly about it today. The basics of Sphinx. Sphinx is very easy to set up. You install it, pip install it, and then you run this bootstrap command, and then after answering a couple of questions, you get a project skeleton. Then you can build your documentation using make.html, and well, if you use Python, you can serve it, and then you can view the docs in the browser, the docs that are generated. But it's capable of generating documentation in many formats, such as EPUB, PDF, pretty much everything that you want. A little bit of a background. So a couple of years ago, I was studying the Rust programming language, and I was amazed by how perfect, how useful the Rust documentation is. So not only it's well structured and extremely consistent, it's also technically very useful. So, but you see, like all snippets, all code snippets, they have file names, because Python is a different language, and in Rust, mostly how you evaluate the code, you just paste it in your editor, and then you compile the code, and then it runs. So for Rust, it's very important to have this part, the file name, so that you know where do you actually need to paste the code. And so all the listings also are very well numbered, so it's it's easy to find. But also there is this icon, icon, and what it does, it shows you the entire file. So in Rust, in documentation, all the snippets are always complete code, but they draw emphasis on the most important part by hiding the irrelevant parts. But if you just want to try it out, you can just copy the whole snippet and you paste it, and you never get an unworking snippet. And as you move on, for instance, they explain what struct is, and then they come to the usage example. And the main is the entry point, and then they say, okay, so this is how you create a user instance. But then you would have to actually scroll up, if documentation wouldn't allow it, to find out what is the definition. But in Rust documentation, you can just click here, and you immediately see this. So all the codes that they have they are like fully workable, and they gradually evolve. So they start with simple, go to more complex, but they do not repeat themselves. They don't have to, but always, if user wants it, he can get the full picture. And I liked it very much. And I was wondering whether I can do something like that with Restructured Text and Sphinx. It was not possible out of the box. And there I started my investigation. I made a step back, and I first, because I had written a lot of documentation by the time already, and I was wondering, so what it is that I'm missing in what I write, and it all came back to actually exposing the code snippets. And what I wanted for my code snippets, I wanted them to be compact, expandable, as you have just seen in the Rust example, and I wanted them to be testable. Because you know how many times there have been cases where you just go to some open source project and you copy-paste code, and then it doesn't work because they have changed the namespace, or they have changed the module name, the package name, and because documentation is not tested. They do not see that it's failing. So I wanted to have that as a must in my the core improvements that I wanted to make. And these are my findings. So, of course, I want to investigate whether something like that was already available on the market. And I investigated these three packages. So on the left, there's this project called Sphinx Design, which is great if you write documentation in Sphinx and you ever missed any visual elements, like grids, more freedom in using the fonts that you have, icons. That is a project for you to start using. And the Sphinx toolbox, by the way, the Sphinx, it had this feature that I sort of liked, that I wanted to use, but it did not work very well according to my requirements. And the Sphinx toolbox, it had also this feature, but it also didn't work according to my requirements. And the PyTest RST was a project to actually test code inside the code blocks. I think it's an amazing project. I'm using it in all the things that I on documentation I write to ensure that my snippets are correct. But so this combination did not work for me, and I started to investigate further. Yeah. So as I mentioned, the combination of these three tools it's actually either Sphinx Design and PyTest, or Sphinx Toolbox with PyTest RST. So they both delivered the compact. They made my snippets compact, and they made them expandable, but they made the testable part even worse. So I went on. I went on to the basics of Sphinx. That's something I haven't done before, because it was so simple. I just learned it by example, learned it by seeing others' code. But I never really read it from A to Z, and that's where I went back to. So I read it from A to Z, and I have rediscovered some of the directives of Sphinx that I haven't properly studied before. So this literary include, I saw it some time ago. But what it does is you simply here you include the code that you want to be included in your documentation, and you tell it instructed what the language is. And then it's being rendered for you. So simply similar to the code block, but you just include it from a file. And is in contrast with code blocks. So this is how you do it with code blocks. You just simply paste the code, and it's rendered just as it's rendered. So what I did not know, what I missed, is that this literal include, it has also lines section. And in lines you can give the number of lines, provide number of lines that you want to have rendered only. So only these lines that will be rendered in your documentation. So that makes my snippets compact. So you hide all irrelevant parts, and you show only relevant parts. The compact checkbox is checked, and we go further. Now, there is this download directive in Sphinx. So this is the syntax. You point it to a file, and it generates a link to where that file is offered to download. So it does all the magic by itself. It puts it into the statics, and then it's offered to download, and it renders as well, similar to this. But when you click it, at best, that file is either opened in a new tab or offered for download, and then you can open it in your favorite editor. But that's not user-friendly. That's not what I wanted out. Like in Rust documentation, I wanted it to be like viewable, just in place, right there, for the user to be really comfortable with it. Yeah, that's not user-friendly. So I went on. Idea. You could use JavaScript for fetching the snippet and showing it in line. But that might be too obtrusive, because if your current documentation, if your current project depends on the download directive, you don't want to change that behavior for all existing users. And one of the solutions that I found for it, so the Sphinx also has this container directive, which simply wraps your code with another class. And then you can execute your JavaScript selectively. So only links that you wrap in this container with a class JSphinx download will be applied, the JavaScript will be applied to that code only. And as HTML, it will be rendered as this. So in contrast from this, you see that there's just one class, one wrapper extra here, which makes it very easy for us to work. And what you get is here. So your file is displayed in line. Your code snippet is fetched and shown in line, but with no syntax highlighting, which is not what you want. And the solution in this case is to use a Prism.js. Prism.js is a library that can you give it the code as a text, and you say which syntax, which language it should be using, and then it simply highlights it in a language that you want. And oh, sorry, this is expanded. So, but it comes to this link. So, and this is how it works. You just click, and then it's expanded. And to give you even more examples, so this is the examples of using the JSphinx, and you have this. The example number one, it talks about some code, and you can see the full example here. So note that here you have assertions. It means that if you somehow manage to run this code through your test suite, then you could actually, well, not only ensure that your imports are correct, but your assertions also correct. And initially you hide the code, so you get what you want, but then it's expandable. And this is the example from the snippet from which this code was rendered. And so as you move on with example 2, which is continuation of the example 1, you only show the relevant stuff. And you can see it here, if you like. You can see the full picture. And so this one works with literal include. But I wanted to make it to work with code block as well, and it does. So it works with the code block as well, with slight difference that so code block also has this emphasize lines feature, which normally just renders just the snippet in full, but it just has some emphasis on the lines, just like this, you know. So if I expand this, you see some of the lines are highlighted, and these are the lines that I marked as emphasized. So initially you show only emphasized lines, and if you click, you can expand. And this is how it works. You wrap your code block into another container called JSphinx toggle emphasis, and that's how you get the functionality. So the expandable part is solved. So packages to use. The JSphinx is a plugin. It's not a Python package, it's a JavaScript library. And this is what you add to your Sphinx configuration. Most of the themes it's very likely that your theme will be supported. But then you have doubts. Should I run code quality checks on my code examples? If you have code examples with that you have with a literal include, that you include them from files. Should you run code checks on them? Absolutely yes, of course. And well, as some of you may know, that some of the code examples, well, sometimes the lines are too long, or you want your MyPy to stop nagging about some issue that you think is okay. You add pragma comments, and if you don't do anything about it, if you use literal include, this pragma comments will be included in your documentation too. But no worries, you can use Sphinx no pragma, which strips all the pragma comments from your documentation, from the generated documentation. This is how you install it and how you configure it. You add it to the Sphinx configuration. So PyTest RST, it's also a good buddy, although it only runs the code inside the code blocks, but it does it very nicely with some gotchas. So in order for it to work, you need to name your code blocks, and it should start with test, and then PyTest RST will pick it up. Easy to install, and because it's a PyTest plugin, it runs automatically. The pros, it works very well for simple code snippets. The cons, it's not suitable for complex code snippets. So if your code examples span multiple modules, that doesn't work. It's not suitable for mocking at all. So if you need mocking, you even with simple code snippets like that are defined inside one module, you better not use this because well, you cannot mock anything. So more about testing the code snippets. It makes sense to distinguish between the simple code snippets that are defined inside of a single module and complex that might span across multiple modules. And the snippets complex code snippets might look like this. The complex package, and then you have your modules, factories, and models, and then you have tests for each of them. So if you have complex code snippets, this is the way you should do it. For simple code snippets, it could be this as well, but it's a bit. You need to write tests for. You create a file, create a new module for each snippet that you have. Or the structure can be actually simplified to this. So you only have code snippets, and if your code snippets contain assertions, given that they contain assertions, you can write a simple script like this that would grab all the contents of all the modules and execute them just like that. So you don't have to write tests for each of your code snippets as long as you have some assertions there. And at the worst, it will ensure that none of the imports are broken there. It's better than doing nothing. And well, in this file, you can add as many fixtures, PyTest fixtures as you like. So all the mocking is very well doable here. And yeah, this is the shell. So oh yeah, I need to source. And go to Pygrunn. Okay, let me run my tests. By the way, this presentation has been written in restructured text, and all my code snippets are tested as well. As you see, that's the presentation RST, that's the file of presentation. It contains some tests, and they're all passed. So if I want my test to fail, I can edit the tests nano, and I'll make an example assertion to something that is not correct. I'll change it to tomorrow. And I'll run the test suite again, and that file will fail. Yeah, so I need to edit it back because I don't want my documentation to fail. And it will pass again. Passing, everything is brilliant. Let's move on. So it's testable as well. There are naturally limitations and drawbacks here, because so using this technique, because we're using JavaScript for doing the fancy stuff, fetching snippets in line, rendering of PDF and EPUB will not be possible. Or it will be possible, but you don't get the fancy stuff. So if that's your core functionality, you can mitigate it differently, because normally in this, if you generate a PDF or EPUB, then you create a different appendix where you include your snippets, and then you can refer to them. And luckily, Sphinx has ways of doing it. So there's this only directive, and then you say for which medium you want to this part of the code to be rendered. So you can selectively render things. And one of the drawbacks is that literal include is less human readable than code block. Again, going back to this, so this is the code block, and this is literal include. So in code block, you immediately see what the code is, and in literal include, you see a link to a file. So you have to go back there and see it with your eyes. But you know, it's a balance. So documentation is read much more often than it's written. The win is quite obvious there. And the alternatives are, so remember when in the beginning I told you I tested out 3 things. And so then I did not yet consider the literal include. But this is how Sphinx designed this drop-down component works. You have this, you click and you get the full example, and this is how you actually define it. So there's this some code block, and then you have the drop-down, and then you place the full snippet inside this drop-down. But this is actually bad, because this part of the code you will never be able to test. It's a partial snippet, and your test will fail. So you should be very careful with this. A better idea would be if you're using, so the obvious pro is that it works for simply code blocks and rendered nicely even with vanilla restructured text renderers. Concerns is that mistakes in compact unfolded snippets are inevitable, and it's not suitable for complex code snippets and for mocking. A better idea would be even this, to actually, it works in the same way, but then you use literal include. So you include your small snippet, and then you include your full snippet. That would work too. It works for all code snippets, and your snippets are still testable. Concerns, like none, except that it doesn't work for code blocks. So for code block, if you use code blocks, you should still find another solution for yourself of how to do it. It's easy to install and configure. So there's this Sphinx toolbox, which works similarly. It has this collapsed component, and it has the same pros and cons and the same drawbacks. Yes. So I'm going to give you some tips on writing documentation. So test your documentation code snippets. If you use literal include, you can use the normal Python for it. If you use code blocks, test your snippets using PyTest RST. For clarity, when it's relevant, show the file names of the code snippet, because it will help your readers to understand you better. Use JSphinx, Sphinx Design, or similar to reduce the cognitive load. So don't burst your users with a lot of code at once. And start simple by gradually evolving. Try to avoid partial code in code block directives. Use it only for code that does not require mocking when tested. And if it does, use literal include. And do not use Sphinx-specific markup in your main README, like literal include. It may go well on GitHub, but if you publish your project on PyPy, PyPy checker is much more strict, so it might result into rejecting to your package to publish. So be very mindful of what you put inside README, of your main README, if that's what you use as a source for your description on PyPy. And if you want to sell more, just generate it using Sphinx in a complex and make a link from your main README into that page. And my last suggestion would be, once everything is perfect, take 2 months break, then come back and try to understand how it works. And, well, there are some links to the projects and packages I recommend to use. This is the JSphinx, the JavaScript library, Sphinx.pragma to strip the Pragma comments. The PyTest RST is a tool to test your code inside the code block snippets. And the Sphinx design is a great package to use. And if you are a Markdown user, this Mosquito, he also wrote a plugin to test code snippets for Markdown. And by the way, these similar tools are available for Markdown as well, but I'm not a Markdown guy. I just checked it. Okay, useful to know, as I said, this presentation has been created using Review.js, and somebody did a great job on writing a plugin for restructured text. So I wrote this entire presentation in restructured text, and that allowed me to use anything like iframe. I never needed to go out of this presentation in order to do something. Even executing comments on my computer, I just did it all from one presentation, so I don't shift focus. And do you have any questions?